So I just watched this really cool video from this guy that is using a hyperbolic paraboloid, which is the saddle or the Dorito shape, to create a physical simulation of a Paul trap, which is a device that captures ions using oscillating electric fields. The video is really good, I highly suggest you guys watch it. The channel is called Nerd Sniped, I'll put a link in the description. And I'm just gonna play this video for a second because I don't wanna steal this guy's content, right? But I thought it was really cool. And then I thought, hey, do you think I can simulate this thing in Unreal Engine? That would be kind of cool. So this is what I did. I'm just gonna show what I did really quick. Like, I'm not gonna do this whole thing again, but I'll just show you guys what I did. So Blender has this add-on that I'm pretty sure comes with Blender. It's this extra mesh objects. If you have this, you can add a new mesh and find math functions over here, XYZ math surface, and then you can create your math function over here. So I'll just put the function in the screen that I used to create this thing over here, right? And basically it was just this upper part, and then I extruded the sides to make this base. And then after this, I used a couple of scripts to take each one of these loops over here and extract them like this, and then select these edges, do a face like this on each side, and then select this whole thing and do a triangulate faces, so you get something like this. And then basically do this for every single one of these slices, right? And the reason is Unreal Engine needs a convex shape to use as a collision surface, and this surface here is not convex, it's concave because of this, right? But if you take these individual slices, because they are one face wide, they are each convex if you add these faces on the side, right? So if you create each of these individual slices like this and put them together, you get this whole shape in a combination of convex volumes, right? And if you name this like this, starting with UCX over here, and you export this along with your main mesh, Unreal Engine will consider these shapes here as collision surfaces. So then I can go into Unreal Engine and import all of this. So here I have my saddle imported into Unreal. And if I go here and in this eyeball thing and click on simple collision, you're gonna see that it's simple because it's a combination of convex shapes, right? But it's not really simple, it's like really detailed, but it's perfectly exactly the same as the original shape. And I was a bit worried that this wouldn't perform very well. It actually performed really well in the end. So I just threw the thing here and I edited the size a little bit, the scale. If you make it exactly the same, it doesn't really work really well, it like shoots the ball off. But I found that this shape here, this ball shaped over here, works really well. I also changed the mass, so if this ball is too light, it also like loses control and flies off. So I just changed this mass scale to 10 and I tested a bunch of speeds. I made a blueprint here with the saddle and I just made a simple function here in the tick event to update the rotation based on this angular speed that I have. So we can see that if I use an angular speed that is too low, the ball quickly falls off, right? And if this is too fast, the ball actually stays stable for a little bit, but then eventually it gets shot off really hard. Actually, I've been watching this for a while and this is surprisingly stable actually. But I tried several different speeds and this 3.7 here seems to be the best one. So I just watched this do this thing for like 5 minutes and this thing is always in the center. It starts falling off and then it gets pushed back up. It's really cool, man. So yeah, I don't know exactly what the point of this video is, except to say that, like, obviously Unreal Engine is not made, it was not designed to simulate complex physical interactions for mathematical purposes, right? But I still think it's really cool that you can take something like this and put it in Unreal and it kind of works, you know? Isn't that fun? Imagine you can test a lot of different things here. Of course, you can't really take the results too seriously, but it's a fun thing to play around with, you know. Certainly creates a lot of different possibilities to make games that use cool physical interactions like this, you know. Anyway, I really recommend you guys watch the original video. It's really cool. I'm gonna put the link in the description, so go check them out. Well, that's it. See ya.